Today we'll be talking about the average rate of change. So I want all of you to highlight this right here. If you ever see that really in any problem, you have to think of that as simply find the slope. And recall our slope formula is simply change in y divided by the change in x. So right here it says find the average rate of change in this function, f of x equals 3x squared. So I'll just underline that for a second. And it says from 1 to 3. So what that means is we're looking at when x is 1 to when x is 3. Now notice how it doesn't give you two full coordinates, but you do have the x part 1 and 3. So that's what you do. 1 comma something and 3 comma something. What you gotta do is figure out what is that y part, and notice how they give you an equation. So take that 1, plug it in, that's just 3. Take this 3, plug it in, that's just 27. So now I can find my slope. M is equal to 27 minus 3 divided by 3 minus 1. And that's going to be 24 over 2, which is 12. So right there, that's your average rate of change. So let's try the next one. From 1 to 5, so I'll just write that 1 comma something and 5 comma something. Plug in 1, that would be 3 again. Plug in 5, that would be 75. And now we'll do the same process. M is equal to 75 minus 3 over 5 minus 1. That is 72 over 4, which is 18. Okay, last one here. So now you're seeing the pattern of this 1, 3, and 7. Plug in 7, that would be 147. So M is going to be 144 divided by 6, which is again a nice number, 24. Alright, so mechanically this is quite simple, but I really need you guys to understand conceptually what is happening. So to show you that, I'm going to get our calculator. So you can use your app or the actual calculator. I'm going to use my TI-84 app right here. I'm going to go to y equals, so again the top left button, type in 3x squared, and then I'm going to graph it. So the standard graph right here, that looks great, it's a parabola, but I'm going to change the window setting. To do that, you're going to hit window. So again, that window button is right next to y equals. I'm tapping it right here on the screen so you can see it. So follow my window settings here. I want my x min to be 0. That means the min x value, or the minimum, should be 0. I want my max to be 7, and you'll see why once we do it while I'm doing this. This is x scale, so meaning each tick mark should be 1. That's good. My y min, I want that to be 0. And I'm going to make my y max 150 should be good. So I'll put 150. And my y scale be, I'll put that to be 15, meaning each tick mark should be 15 units. And I'm going to graph it, and there we go. So there's our nice curve all in quadrant 1. So let's screenshot that. And I'm going to copy this over to our Notability document. So there's our graph right there. And I'm going to show you what we were doing. So I'll make this one black. I'll make this one blue. And I'll make this one red. So 1, 3, that's right here. 1 comma 3. And the first one was 327. So looking at our graph, that's right here. Essentially what we just did, right, is we found the slope between these 2 points. So imagine you just connect them like that. What we found is the slope of that line was 12. And what's cool about that is this is actually called something. That's called a secant line. So that's when you just connect 2 dots in this manner and connect them. it creates what's called a secant line. So if I keep following that, the next one, I'll do that in blue. It uses the same .13, but it goes to 575. So that's about right there. I'm going to connect them. Right here, we found that the slope of that line was 18. And the last one, we'll do that in red. That was to 7,147, so that's right here. So that's why I made it to 150. If I connect this one to the 1,3, something like that, that's good enough. I know that this slope is 24. So again, that's just giving you some context into what's actually happening when you're doing this math. So now you're seeing, it says finding the equation of the secant line. So those lines we were drawing here, now I'll talk about, well, let's actually find them. So it says, suppose you're given this graph, or this function, find the average rate of change from -2 to 1. Okay, so that's no problem. Let's find our coordinates. So -2 comma something, 1 comma something. Okay, so plug in -2, that's 3 times 4 is 12. 12 plus 4 is 16, plus 3 is 19. Plug in 1, 3 minus 2 plus 3, that is 4. So there's our 2 points. Now we're going to write m is equal to 4 minus 19 over 1 minus -2. That is -15 over 3. So we found our slope, -5. Right there. So A is done. Now it says find an equation of the secant line containing the 2 points. So notice how I have a slope and I have 2 points. So let's use our simple point slope form. So recall that one. Y minus y1 is m times x minus x1. Doesn't matter which point you pick, but I'll pick the easy one, 1, 4. So y minus 4 is equal to -5 times x minus 1. And right there is our equation of the line. And just in case you wanted slope-intercept form, let's go a little further. That'd be y is equal to -5x plus 9 if you just solve for y there. So again, that would be slope-intercept form. Okay, so those two are done, not too bad. Part C, use a graphing utility to draw the graph and the secant line obtained on the same screen. All right, so it wants us to really see what's happening. So let's go back to our calculator. Sorry, wrong one, this one. And we're going to type this in. 3x squared minus 2x plus 3. And then we have -5x plus 9. Okay, so now when you notice when I graph this thing, you're going to see something interesting happen. We're still in quadrant 1. I really can't see much. So to fix it, this is the simplest way. We're going to hit zoom and then number 6 for Z standard. So that should standardize it. And you notice how it's still not that great. So I'm just going to manipulate my window setting a little bit. I'm just going to change my Y max. I'm going to get rid of this. I'll make this 20. And then I'm going to change this back down to 1. And then, okay, a little better. So again, if you go to your window setting, just copy this over, and that should make your graph a little bit nicer to look at. Okay, so let's copy this over. Okay, so here is the graph. And this graph is pretty cool because we can see the 2 points of intersection right there. That one is -2, 19. And this one right here, that one is 1, 4. And what we just found is a secant line right here. That's your secant line is connecting them. And that equation are the two things we just found right there. All right, and that's it for that. Okay, so here's the last one. Advanced rate of change problem. Find the average rate of change for the given function from 1.5 f of 1.5 to x f of x. All right, so our 2 points we're going to use, we have 3 over 2 comma f of 3 over 2, and then x f of x. So x, and let's plug in for f of x, that's just 5x minus 3. So the problem right now is f of 3 over 2. We just have to evaluate that. So on the side, let's just figure that out. So f of 3 over 2, that's just 5 times 3 over 2 minus 3. That's 15 over 2 minus 3. That would be 9 over 2. So now I can plug that in. Let's get rid of this. And now let's do our average rate of change. So the slope should be 5x minus 3 minus 9 over 2, all divided by x minus 3 over 2. Let's get rid of the complex fractions by multiplying by 2 over 2. That would be 10x minus 6 minus 9 over 2x minus 3. Okay, let's combine those. That's just 15. And this actually is pretty interesting because this can be factored. That's 5 times 2x minus 3. And notice how these cancel here, which means we get 5. Which is interesting because notice how in the problem we're dealing with the line. And 5 is actually the given slope, m equals 5. Which means we could actually do this formula or this process for any 2 points on this line, and we should get 5. Because no matter what, the average rate of change should be 5. So what I mean by that is, imagine we actually graphed it. 5x minus 3 would look something like this. Again, this is a rough sketch. Because it's a line, you could pick 2 points anywhere. And then if you connect them, you get the same line. So imagine you actually connect these two things. Which means, of course, the average rate of change is 5 because you're landing on the same line. Okay, so that's it for the questions. Let me know if you have any questions in the homework, and I will see you in class.